Good morning, dear friends. Today we shall discuss about invertible functions. Invertible function. Suppose we have a function f. If f of x is a function f from R to R, and if there exists another function g of y such that f composite g is equal to g composite f equal to identity function I, then f is called invertible function. F is called invertible function, and g of y is called inverse of function f of x, and we write that as f inverse of y is equal to g of y. So, f is a function, and if there exists another function g, so that f composite g and g composite f is identity function I, then f we call as a invertible function, means its inverse exists, and g is called inverse of f. That is, f composite g of y is y, and that is IB. F is a function from A to B it is, and g composite f of x is equal to x, and that is IA. Means here we have a function f from set A to set B. X is the element of the set A, y is the element of the set B, x are related to y is image of x, and we write that as f of x equal to y. So, here f is a function from A to B, then its inverse is a g, and it is a function from B to A. It is a function from B to A, and this is your g, which is nothing but f inverse, and here this is y and this is x here. So, y is image of x, so here y becomes pre-image of x, and x is pre-image of y, but here x is image of y, and here x is image of y. So, we write this as f inverse of y is equal to x. Means, remember, when we have f of x equal to y, then f inverse of y equal to x. So, f inverse is a function from B to A. Remember, when we have a function f, which is bijective means 1 1 and on 2, then only its inverse exists, and it is a function g from b to a, which is f inverse of y equal to x. So, f inverse is g, and that g is a function from b to a, So, remember f is a function from a to b is 1 1 and on 2, 1 1 and on 2 means it is bijective function. Then f inverse means it is g is a function from b to a, So, if f of x is equal to y, then this implies by x equal to f inverse of y. So, remember function should be 1 1 and on 2, then only its inverse exists, otherwise its inverse does not exist. For example, I take here this is a set A, here this set B, and f is a function from a to b. I take here a, b, c, 1, 2, 3, a related to 3, b related to 1, and c related to 2. Then here f of a is equal to 3, f of b is related to 1 means f of b equal to 1, and f of c is equal to 2. Then this function is 1 1 and on 2, Why this function is 1 1 and on 2? Because each image have only one pre-image, 1 have only one pre-image b, 2 have only one pre-image c, 3 have only one pre-image a. Means different elements related to different elements. Different elements of set A related to different elements of set B. So, this is 1 1. And why it is on 2? So, here range is a set B 1 2 3, which is also codomain. So, range and codomain are same, therefore, it is 1 1 as well as on 2. Means this function is bijective, and its inverse exists, and it is a function from b to a, here it is 1 2 3 a b c, and this is a inverse of a function f inverse. Look here, 1 related to b means b related to 1 means here 1 related to b, c related to 2 means 2 related to c, and c related to 2 means 2 related to c. Next 3 related to a means a related to 3, and this is a inverse of a function. So, a is image of 3 means we write that as, see here, f inverse of 1, because it is inverse function, f inverse of 1 is b, f inverse of 2 is c, and f inverse of 3 is a. Look here, f of a is 3 means f inverse of 3 is a, f of b is 1 means f inverse of 1 is b, f of c is 2 means f inverse of 2 is c. So, suppose I take a function which is not 1 1, So, this is here a, b, c, then I take 1 2 3. So, a related this, and observe here, this is a function which is neither 1 1 nor on 2. So, suppose here if you try to define its inverse. So, 1 we take their domain and a codomain means 1 related to a and b means this is not a function because one is related to not unique element, one is related to. So, I will write this one. So, this is B, this is A. So, here 1, 2, 3, A, B, C. So, A and B related to 1 means 1 related to A, 1 related to B, and C related to 2 means 2 related to C. So, this is not a function. See here why it is not a function, because 1 is not related to unique element, here 1 is related to 2 elements. So, this is not a function, and after that here it is not 1 1. So, it is its inverse does not exist, and here this is not onto function, because if we take here 3, 3 is not related, means every element of B is not related. So, here inverse what does not exist when the function is not 1 1 and onto. So, a small theorem, inverse of a function is unique, inverse of a function is unique, inverse of a function is unique. If inverse exists, then inverse of a function is unique. Proof of this, let us take G1 and G2. Let, if possible, I take G1 and G2 be two inverses of F. Then this implies G1 is inverse of, since I take G1 is inverse of F, then we get F composite G of Y is equal to G composite F of X is equal to I, or we simply take G1 here, G1 here. Okay. Then also G2 is inverse of F. So, this implies F composite G2 of Y is equal to G2 composite F of X is equal to I. Then from this we get, this is 1 I take and this I take as 2. So, 1 and 2 implies I take F composite G1 of Y is equal to F composite G2 of Y, and this implies F of G of Y, G1 of Y, and this implies F of G2 of Y, and this implies G1 equal to G2, because F is which function? 1 1 function, means F of x1 equal to F of x2 implies x1 equal to x2 means G1 is equal to G2, means G1 and G2 are not different, but they are same. Therefore, inverse of a function is unique, means there does not exist two functions which are the inverse of the same function f. Therefore, inverse of a function is unique. Now, here on this part you are getting one question for 5 marks, and that is on question number 39, first question in the part D, and I am taking this function. Consider a function f from R to R given by f of x equal to 4x plus 3. Show that f is invertible. Find the inverse of f. Consider a function f from R to R given by f of x equal to 4x plus 3. Show that f is invertible. Find the inverse of f. And when the function f is invertible, there should be another function g must exist, so that f composite g and g composite f equal to I. Then we say that f is invertible, and we find out the inverse of f, means that is g of y is nothing but inverse of f, which is f inverse of y. So, remember the method is, so first it is given f of x is equal to 4x plus 3, which is a function from R to R. Domain is R, codomain is R. Then look here, first of all you have to find out g of y and how that g of y is found. You know the method of proving onto function. We follow the same way. Let f of x equal to y, where y belongs to R, which is codomain, you know that already, and from this get the value of x in terms of y, and that is your g of y. Remember here. So I put the value of f of x, which is 4x plus 3, which is equal to y. From this we get 4x is equal to y minus 3, and this implies x is equal to y minus 3 divided by 4, and this is nothing but your g of y, which is y minus 3 divided by 4, which is your 2, and this is your 1. Means defining g from R to R. Remember, f is a function from a to b, then g is a function from b to a, means it is R to R, means it is also R to R, by g of y is equal to y minus 3 divided by 4. Then our aim is to prove that f composite g and g composite f is I, therefore f is invertible function, and this g of y is your inverse of a function f. So here I take first f composite g of y, which is f of g of y. We know already how the composite function is taken. Remove this o and put the flower. I write f of y, g of y means I put the value which is y minus 3 divided by 4. Next f of y minus 3 by 4 means your f of x is 4x plus 3, but your x is, this whole bracket is your x. So I write 4 x means I write this x as y minus 3 divided by 4 plus this 3. So this 4 and this 4 get cancelled, y minus 3 and this plus 3 minus 3 get cancelled, and y, and this is your nothing but identity function R, because x, y, which is element of codomain. So we write IR, which is R is here, B, which is codomain. Now let us take g composite f of x, and that is g of f of x. I write here g of f of x means I put this value which is 4x plus 3, and g of 4x plus 3 means g of y is y minus 3, but your y is this. Look here, g of y means y is 4x plus 3. So I write here 4x plus 3, this is y minus 3 divided by 4, plus 3 minus 3 get cancelled, it is 4x divided by 4 get cancelled, x, and this is IA, but IA is your domain, which is IR. So this is your number 3, this is your number 4. So 3 and 4 implies f composite g is equal to g composite f is equal to I. So hence f is invertible. F is invertible function where f inverse of y is nothing but it is g of y, and what your g of y is y minus 3 divided by 4. This is your final answer. So, look here what the method is. Remember, first of all, how to get the value of g of y means another function g of y is found. What that method is, same thing what you have done in case of proving function onto or not onto into. For that, f of x equal to y is taken and we get the value of x in terms of y, and that is your g of y, and we define g from here. F is a function from a to b means g is a function from b to a, which is defined by g of y means the value of x whatever you get, that is your g of y, and that is y minus 3 divided by 4. And next your aim is to prove that f composite g is I and g composite f is I means f composite g, g composite f is I means f is invertible function, and the inverse function is f inverse of y, and that is your g of y. So, remember the method, and for this when you define this means you get the value. For this 1 mark is there, for 1 mark is there, for proving this 1 mark is there, and for proving this 1 mark is there, means here for this step 1 mark means getting g of y is 1 mark, proving f composite g is IR I 1 mark, g composite f proving 1 mark means total here we got 3, and writing that this identity, and hence f is invertible. For this 1 mark is there, 1 mark is there, and writing the inverse for this 1 mark is there. So, total marks are 5. So, this is a question for 5 marks, and which is one of the important question. So, remember the method and write whatever here I have given in the same way. Don't make any mistake. Right here, see how we found g of y, and we have to define g from b to a, which we should write that one, for which 1 mark is there. After that, f composite g and g composite f, you have to prove that I, and you have to write this step for which 1 mark is there, and finally writing the inverse. After that, I take another example. F is a function. See here, f is a function from r plus to semi open interval 4 infinity given by f of x equal to x square plus 4. Show that f is invertible with f inverse of f given by f inverse y is root of y minus 4, where r plus is the set of all non-negative real number, means all positive real numbers including 0 means there does not exist negative real number in this r plus. 0 is there, all positive numbers are there, 0 is there, but negative numbers are not there. So, let us take here first I write that as given f of x, which is root of x square plus 4, this is your 1, and here a function from r plus to 4 infinity, r plus to 4 infinity. This is your a, I write that one, and this is your b. So, domain is r plus a, codomain is b, which is semi open interval 4 infinity. You have to define g from b to a means 4 infinity to r plus. So, for that you know the method. Let f of x equal to y, and this y belongs to codomain means 4 infinity, which is codomain. So, this implies I put the value of f of x, here root of x square plus 4, I put the value. So, f of x is x square plus 4, this is your 1, there is no square root. So, I write here x square plus 4, I put the value of f of x square plus 4, which is equal to y, and this implies x square is equal to y minus 4, and this implies x is equal to plus or minus root of y minus 4. So, we got here two values, one is plus, another is minus, but minus root of y minus 4 is not admissible value, because we have domain. This is the element which belongs to the domain, but this minus root of y minus 4 does not belongs to R plus. So, since x equal to minus root of y minus 4 does not belongs to R plus, means it is not positive real number. So, this implies x is not equal to root of y minus 4. So, this implies your value of x is root of y minus 4, and this is your g of y, which is root of y minus 4. So, defining g from b to a, means it is 4 infinity semi open interval to R plus by g of y is equal to root of y minus 4, and this is your equation 2. This is your equation 1. See here 1 and this is 2. Now, next f composite g and g composite f, we have to prove that equal to I. So, first I take f composite g of y, always g of y taken, f of x is taken, and this is f of g of y. I put the value of g of y is root of y minus 4, and f of root of y minus 4 means f of x is x square, but your x is, see here, your x is root of y minus 4 means x square, means it is root of y minus 4 whole square plus 4, and this is y minus 4 root cancel plus 4 get cancel y, and this is nothing but I b. What is your b? I write that as 4 infinity, and this is your equation number 3. Now, I take g composite f of x, which is g of f of x, and that equal to g of f of x, means it is x square plus 4, and that equal to g of y, which is here root of y minus 4. So, root of y is here x square plus 4, y means I write here root of x square plus 4, y minus 4 means this is minus 4, plus 4 minus 4 cancels, it is root of x square, and root of x square is x, and this is your I a, but what your a is R plus it is. You must be very particular here writing this. This is 4, means 3 and 4, equations 3 and 4 implies f composite g equal to g composite f equal to I, and this implies f is invertible function. F is invertible function, where f inverse of y is equal to g of y, and your g of y is root of y minus 4. And same way for defining this, here it is 1 mark here. Proving this equation, here it is 1 mark, here it is 1 mark, and writing this invertibility, it is 1 mark, and here it is 1 mark, means totally 5 marks. Okay, we shall stop here. So, these are the 2 very important examples. 3 more important examples are there. I will take those, and next I will solve the remaining examples which are not asked so far in the examination, but you have to work those examples also. Okay, my dear friends, thank you.